All right, good morning, everybody. Hope you guys are doing well. Today we're going to continue to discuss some logarithmic and exponential equations. I'm going to show you some more examples here. Just an FYI, this is the next to the last lecture that I'm going to be posting this year. So this is exciting. We're almost to the end of online lectures, which is great. You guys have had um, a an interesting end to the school year, to say the least. I don't think any of us would have expected this, is for sure. So we're getting close, guys. So, anyways, so this is 5-4 continued, and let's get started. So we are going to solve the following exponential equation, and that is e to the x plus 5 equals 60. So the first thing you want to do, as I had said in our previous lecture, is if you have a base and a power and there's anything else with it, whether it would be a number multiplying, dividing, adding, subtracting, we want to get all the other numbers except for the base and its power moved to the other side. So we're going to subtract 5 from both sides, and we're going to end up with e to the x equals 55. Now that we have e to the x equals 55, we are going to log both sides of the equation so we can get the x down out of the exponent position. So since this exponential is base e, we're going to use natural log, and so we're going to natural log both sides of the equation. And now we can utilize the power property, which allows us to bring this x down and in front of the natural log. From there, you can see we have natural log of e. That is one of our log properties that states that if your log has the same base as the number that is being logged, then it will all cancel out and turn into 1. So this is log base e of e, otherwise known as natural log of e. So this whole part right here cancels, and then you are simply left with x equals natural log of 55. And that's your final answer. You can leave it just like that. If you want to get it decimal, you can. It's not necessary, unless the directions specifically say so. Okay, the next one, solve the following equation. And this one has a lot more stuff going on with the exponent. So all of that's going to need to be peeled away first before we can start dealing with the exponent itself. So we have 2 times the parentheses 3 to the 2t minus 5 and minus 4. You're actually going to get rid of the minus 4 first by adding 4 to both sides. Followed by that, you are going to divide both sides by 2. And so now what you can see is we have our expression. So it's just a base and a power on the one side, which is what you want to get it as. Now, the only way to get this variable down and out of the exponent position is to utilize the power property, but to utilize the power property, we need to have a log. So we're actually going to log both sides of the equation here. Because this is base 3, we're going to use log base 3. So you always want your log base to match the base of the exponent. So we're going to do log base 3 of 3 to the 2t minus 5, and that's going to equal log base 3 of 15 over 2. Now that we have log base 3 of 3, this 2t right here, this 2t minus 5, is able to be brought down and in front of the log, and you have this log base 3 of 3. And as you saw in the previous problem, if the log base matches the number that is being logged, it all cancels and just turns into 1. So this 2t minus 5 is going to come down front, and the log base 3 of 3 is going to go away. And that's why you see we only have 2t minus 5 on this side, and then this log base 3 on this side is still there, obviously, because 15 over 2 doesn't match 3. Now, moving on to solve the rest of this, you can see we have 2t minus 5. We're going to get rid of the minus 5 by adding 5 to both sides. So we end up with 5 plus log base 3 of 15 over 2. And finally, we're going to divide both sides of the expression or the equation by 2. And you're going to get your final answer, which is 5 plus log base 3 of 15 over 2, all divided by 2. And there's your final answer to that equation. If you want to type that into your calculator, you can. You would get about 3.417, but it's not necessary unless the directions say so. So another strategy that I discussed yesterday in yesterday's lecture, we're going to do a little bit more practicing with those, is how to just take something out of exponential form and put it in logarithmic form, or take it out of logarithmic form and put it into exponential form. And so that's what we're going to do in this example 5a. You can see we have natural log of x equals 2. The variable is being logged. Anytime the variable is what is being logged, you should automatically think in your head, I need to move this from logarithmic form into exponential form. And so that involves just figuring out what the base is. This is natural log, so the base is e. So it's e, and then the x and the 2 switch places. So it's going to be e to the second equals x. And when I move that into, you can kind of skip this middle step because that's not the way that I've taught you how to do this. Um, this last step, e to the second equals x. So you go from the base to this power equals there. You have your answer. X is e to the second. Here's another one. This is log base 3 of 5x minus 1 equals log base 3 of x plus 7. If you notice, this is log base 3 on this side, this is log base 3 on this side, and it's saying that these expressions are equal. So this is a case where we're going to be able to utilize the one-to-one property and simply set 5x minus 1 equal to x plus 7. And from here, this is a problem you guys have solved since Algebra 1. You're going to move the x to the other side. You're going to subtract x. You're going to get 4x minus 1 equals 7. And then you're going to add 1 to both sides. And you'll get 4x equals 8. And then you'll divide both sides by 4. And you'll get x equals 2. That's why I didn't show those steps. I think that's a pretty easy problem. All right, next one. This one's a little bit harder. You can see it's log base 6 across all of the logs. However, we have 2 logs on this side. And before you can utilize the one-to-one property, you've got to get the left-hand side condensed into one log expression, not 2. And another one of our log properties that we had learned allows us that if you have allows us to condense this. And what it's going to utilize is the quotient property. So this is log base 6 of 3x plus 14, and that equals log base 6 of 5. Because these logs are being subtracted and they are the same base, you can condense what is being logged into one single fraction. Again, that's called the quotient property. So you can see now that we have log base 6 of 3x plus 14 over 5. And there's only one log on the left-hand side now. Now, moving forward from there, we can now utilize the one-to-one property because there's a log base 6 here, there's a log base 6 here. It's saying they're equal. In order for these expressions to both be equal to one another, the algebra part, the algebraic expression here with the variables in them need to be equal to one another. So we're going to set 3x plus 14 over 5 equal to 2x. From there, you're going to multiply both sides by 5. Then you're going to subtract 14 and divide by 3. I'm sorry, you're not going to subtract 14. You're going to subtract 3x, and you're going to get 14 equals 7x, and then you'll divide both sides by 7. You'll get x equals 2. All right, guys, that's it for the example problems. Hope you're doing well. There's some more practice problems for you to try, and we are almost done. As I said, we've got one more lecture after today, and that's going to be some word problems, and then I'm going to have some web assignments for you to do, and that's going to be about it. So hope you guys are doing well. Take care.